The table shows the speed in kilometers per hour of 100 cars which moved in the same direction along a straight level route. 1. Draw a cumulative frequency graph of the distribution. So this is a table with the speed given and then the number of cars, which is the frequency. They're asking us to draw a cumulative frequency graph of this distribution. To draw a cumulative frequency graph, we need to first of all come out with a cumulative frequency table. That is a table showing the upper class boundary and the cumulative frequencies of the various classes. To come out with the table, we need to come out with the class boundaries of the various class intervals. Here we have 0 to 9. That's this class 0 to 9. We have 10 to 19, 20 to 29, 30 to 37, 40 to 49, 50 to 59, 60 to 69, 70 to 79. These are the class intervals that they are given. This is the lower class limit for this class. This is the lower class limit. This is the upper class limit. We need to come out with the class boundary of this class. Class boundary is always symbolize CB. You know, we are interested only in the upper class boundaries. To get the upper class boundary here, we need to add these two numbers and we divide by 2. That is 9 plus 10 divided by 2 is equals to 9.5. This 9.5 will be shared by these two class limits. That's the upper class limit here and the lower class limit here. So I will have 9.5 here. The next class boundary will be 10.5. To get this complete class boundary, I need to add 19 plus 20 divided by 2. That's 39 divided by 2. So we're going to have 19.5. So mean that here we have 19.5. This value will be the same for this class. So I have 19.5 here. Also 29 plus 30 divided by 2. That will be 29.5. So mean that here I'll have 29.5 and down here I'll have 29.5. 37 plus 40 over 2 will be 38.5. So mean that here I'm going to have 38.5. So they are going to share the same value. So down here I'm going to have 38.5. 49 plus 50 divided by 2, I'll have 49.5. So here I'll have 49.5 and here I have 49.5. I do the same here. 59 plus 60 divided by 2, I'm going to have 59.5 here. 9.5 and then here is 59.5. The same thing. I mean here I'll have 69.5 and here I'm going to have 69.5 because I've subtracted 0.5 from the lower class limit, so I also add 0.5 to the upper class limit. So here I assume 79.5. The same here because I've added 0.5 to the upper class limit. I got to subtract 0.5 from the lower class limit. So 0 minus 0.5 is going to give me negative 0.5. It means that if we are just subtracting 0.5 from the lower class boundary and adding 0.5 to the upper class boundary, you will see that here we're supposed to have 37.5 in this class, but instead we're having 38.5. Although the lower class boundary is correct, if we are subtracting 0.5 we will have 29.5, but we're adding 0.5, we're instead going to have 37.5 here instead of 38.5, and this can bring us a lot of problems when we are plotting our curve. These are the upper class boundaries. These are the lower class boundaries. We don't need the lower class boundaries. What we need is the upper class boundaries. 9.5, 19.5, 29.5, 38.5, 49.5, 59.5, 69, 69.5, 79.5. These are the upper class boundaries. You see, this symbol here means we have written the upper class boundaries, and it is a method and you need to put it. In the first interval, the frequency is 1, so we write 1. In the second interval, the frequency is 4, so we cumulate with the first one. Cumulate means we take 1 plus 4, which is equals to 5. So mean that here we write 5. In the third interval, the frequency is 11. So we cumulate again. We take 11 plus the previous cumulative frequency, which is 5, and it's going to give us 16. So here we write 16. 27 plus 16, which is 43. Here we write 43. 38 plus 43, 81. So here we write 81. Here we have, in this interval, you have 12. So we are going to take 12 plus 81, which will give us 93. Here we have 4. So we are going to take 4 plus 93, which is going to give us 97. Here we have 3. 3 plus 97 will give us 100. Now the next step is to draw our cumulative frequency curve. This is the way our graph paper looks like. We indicate our origin. Our origin is always starting from O, and here is the y-axis. The y-axis represents the cumulative frequency. The x-axis is the upper class boundary. You always shift your graph one step inside from the left and one step inside from below, so as to create space for your numbers you are going to write here and here. And also, if you need to read a value behind or below the graph. Let's decide the scale on the x-axis. If you look very well, you will see that most of these intervals, that's from 9.5 to 19.5, is the interval is 10 units. From 29.5 to 38.5, the interval is 9 units. That's 38.5 minus 29.5 is 9 units. From here to here is 10 units. From here to here is 10 units. See, most of the intervals are 10 units. So we are going to choose our scale to be 10 units from one value to another. So this is our graph, and you know, on the x-axis, if we take 2 centimeter to be 10 units, it means one of these is 5 units. You can look very well. These are the smaller squares. Here there are 5. You have 1, 2, 3, 4, 5. It means if we take 2 centimeter to stand for 10 units, it means we are going to have 10 smaller squares. That means if we have 10 smaller squares to be 10 units, it means one smaller square will be how many units? So we need to do some simple proportion. That's 1 times 10. We have 1 times 10 over 10, which will be equals to 1 unit. Mean that one smaller square is 1 unit. We need to know what the smaller square stands for so that our counting can be done conveniently. You see, the first value in the x-axis start with 9.5. So between 9.5 and 19.5 is 10 units, and so on between these 10 units, except between these two, that is instead 9 units. So it means that here we are going to write 39.5 on our graph, so that between 29.5 and 39.5 is 9 units. With this, we have not changed anything. We can still plot the value 38.5 if we need to plot it. So we are going to write these values the same they are, except here we are going to write 39.5. So it means that here we have 9.5, 19.5 here, 29.5, 39.5, 49.5, 59.5, 69.5, 79.5. So this was our maximum value, so we can stop here. If we continue, this one will be 89.5. For the y-axis, the smallest value is 1, the highest is 100. In the y-axis, I can still take 2 centimeter to represent 10 units. That's, 2 centimeter is the same like 10 small squares. That means 10 small squares will still represent 10 units. It means one small square will be 1 unit. So I need to know what my one small square will be, because it's going to help me a lot in the counting or in the plotting. I need to go to my graph and I verify if I take the 2 centimeter to stand for 10 units, will my last value 100 be able to enter? That is what you need to find out. This is my y-axis, and here is 10 small squares. That is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So my 100 value is going to enter, will be right up here. And when you are writing the last value, it's always good to leave a smaller space, because you may need to read a value from the graph. Means that here I have 10. 20, 30, 40, 50, 60, 70, 80, 90, 100. Need to plot 9.5 against 1. That's 9.5 is on the x-axis, that's the upper class boundary, and 1 is on the y-axis, that's the cumulative distribution. You know, our 1 small square was 1 unit on the y-axis, and here is 9.5. So I move 1 small square, I have this. So this is the point. I need to plot 19.5 against 5. This is 19.5. On the y-axis, this is 5. This is 10. This is 5. So I move this 19.5 and I plot. I need to plot 29.5 against 16. This is 29.5. 16 on the y-axis. This 10. This 5 is 29.5. So this is 16. 38.5 against 43. 38.5 is here. This is 43. The point is here, so I mark. 49.5 against 81. 49.5 is here. I move up. This is 81. I mark. 59.5 against 93. This is 90. So 93. 1, 2, 3 is here. I mark. 69.5 against 97. So this is 97 here. I mark. 79.5 against 100. Is it here? I mark. So now we need to connect our points. Connect. So we need to make sure that we extend this first point. Extend this one and also extend this one, because we may read a value here or here. Draw a cumulative frequency graph of a distribution from your graph. Estimate B, the median speed. Median is always symbolized as Q2 and is equals to half end position value. Sometimes the formula of median is half n plus 1 position. It is half n position when n is greater than or equals to 50, and is half n plus 1 position when n is less than 50. For this question, n was equals to 100. N is the total frequency, that's the sum of all the frequency, which was the last value of the cumulative frequency, that's 100. It means Q is equals to half into 100 position is equals to 2 here 1, 2 here 50. So Q2 is equals to the 50th value or the 50th speed. Median is equals to the 50th speed or the 50th value. If we place our ruler properly on the 50th frequency and extrapolate until we touch the graph, we turn the ruler to see what value or what speed the 50th value is corresponding to. We place our ruler properly, we will see that. Let's extrapolate down again and see. We extrapolate right to the value on the x-axis. Let's remove our ruler and mark the point where the arrow is pointing. This is 39.5. If you look carefully, we see our arrow is pointing 40.5. This is the 40.5 here. So it means the median is 40.5. It means from the graph, the median is 40.5. So from the graph, the 50th value is 40.5. Means the median is 40.5 and kilometers per hour. So the speed was given in kilometers per hour. So this value, since it's read from the x-axis, should be 40.5 kilometers per hour. Number 12, Roman 1c. The number of cars which we are traveling at a speed greater than 55 kilometers. So to know the number of cars that we are traveling at a speed greater than 55 kilometers, we need to go to the y-axis, read the values. We need to go to the y-axis, read the number of cars that we are traveling at a speed 55 kilometers. When we have the number of cars that we are traveling at 55 kilometers, then we will take now 100 minus that number, since 100 was the total number of cars. So from there we will know the number of cars that we are traveling above 55 kilometers. We need to go now to the x-axis. We extend an arrow, touch the graph, and then we will read the value on the y-axis. This value will be the number of cars that we are traveling at the speed 55 kilometers. To know that the number of vehicles that we are traveling at speed more than 55 kilometers, we need to take the total number of cars minus the total number of vehicles that we are traveling at the speed 55 kilometers. From there will give us the total number of vehicles that were traveling with a speed greater than 55 kilometers. Now 55 kilometers should be here. Since one of the small square was 1 unit, then half of the small square should be 0.5 units. So plus the 54.5 will give 55 kilometers per hour. Extrapolate a line from here until I touch the graph. So the line touches the curve at this point. I will again turn my ruler and read what value is that on the y-axis. If I raise my ruler, if I place my ruler at that point where the line is touching the curve, and I extrapolate again and touch the y-axis, extrapolate until I touch the y-axis. So it touches the y-axis at this point. You see the point where the line is touching the y-axis, it is one unit away from 90. So it means 90 minus 1 will be 89. That means there were 89 cars moving at a speed of 55 kilometers per hour. So number of cars moving at a speed greater than 55 kilometers will be equals to 100 minus 89. Since the total number of cars were 100, so we take 100 minus 89. That's number of cars moving at speed greater than 55 is equals to 11. So it means there were 11 cars altogether moving at a speed greater than 55 kilometers. Number 12, Roman 2. Find the mean of the distribution. The formula to calculate mean is given as summation of fx all over summation f. We already know that summation f is the total frequency, which was 100 from the table that we got. X here is the midpoint, the midpoints. X here is the midpoint of the class interval. To calculate the mean conveniently, we need to come out with a table like this. This is the class interval that were given to us in the question. We need to calculate the midpoint here. You know, the midpoint of this class is given by 0 plus 9 divided by 2, that is 9 over 2, which is 4.5. So here the midpoint is 4.5. Midpoint is always the upper class limit plus the lower class limit divided by 2. So here the upper class limit is 19, the lower class limit is 10. So I am going to take 10 plus 19 divided by 2. That's equals to 29 divided by 2, which will give me 14.5. So here is 14.5. Here the upper class limit is 29, the lower class limit is 20. So here I'm going to take 20 plus 29 divided by 2, that is equals to 24.5. so here the midpoint is 24.5. 30 plus 37 divided by 2, the midpoint is 33.5. 40 plus 49 divided by 2, we have 44.5. 50 plus 59 divided by 2, we have 54.5. 60 plus 69 divided by 2, we have 64.5. 70 plus 79 divided by 2, we have 74.5. Our frequencies as given in the question where you had 1, 4, 11, 27, 38, 12, 4, 3. Fx means 4.5 times 1 is the same like 4.5. 14.5 times 4 is equals to 58. So here I put 58. 24.5 times 11, 269.5. 33.5 times 27, 904.5. 44.5 times 38, 1691. 54.5 times 12, 654. 64.5 times 4, 258. 74.5 times 3, 223.5. Here summation f was equals to 100. Summation fx is adding all these values in our calculator. That we take 4.5 plus 58 plus 269.5 plus 904.5 plus 169, 654, 258 plus this is going to give us 4063. So we can now compute the mean, which is x bar. So x bar is equals to this formula. I put summation fx as I got there. It's equals to 4063 all over summation f, which is 100, which is equals to 40.63. So this is our mean.